Well, good morning, good afternoon, and good evening. Welcome to the Crazy Hat Chemist. So here we go with another awesome video here. And this is going to be on Ionic bonds worksheet number 5. You can see that Roman numeral right there. This is Ionic bonds worksheet number 5. So before you start watching this video, make sure that you have watched the previous 4 videos and you know your ions and charges. So without further ado, let's get moving on each one of these. This is going from the name to the formula. All right, let's rock and roll, baby. Here we go. So this first one is cesium bromide. All these are ionic bonds. That means that there is a cation first, followed by an anion. Furthermore, cations are positively charged and anions are negatively charged. Okay? The net charge of a compound for an ionic compound, that is, must be 0. So what we're going to do is we're going to find cesium. So cesium is actually an element that's on the periodic table and it follows periodic trends. Here is cesium right there. That is a CS and it is in group 1, so it has a 1 plus charge. Alternatively, you can look at my ions and charges oxidation numbers. And if you were to email me in the comment section, send me your email in the comment section, then I will send this to you as a PDF. So here is the cesium ion. It's in the 1 plus category. It is a monoatomic cation, and it's CS with a 1 plus charge. Notice that that is a capital C, a lowercase s. So I'm going to write CS 1 plus. That's my intermediate step. That's my cation. Then I have bromide. Bromide is my anion because it comes second. I'm going to find that on my periodic table. And where is that? That is right here with bromine. That's a Br. And that is a halide ion. So it's in the 1 minus column. Alternatively, you can look at my ions sheet of paper right here, and you will find that the bromide ion is right there. It's in the 1 minus category. It's a B and an R. That's a capital B, lowercase r, and it's a 1 minus. So I'm going to take Br 1 minus, just like that. And then, like I've told you before, you're going to take the bull by the horn, flip, bring it down. And how we do that, what we're going to do is we're going to circle this cationic charge. That's your index finger. We're going to circle this anionic charge. That's your pinky finger. That's take the bull by the horn, flip, bring it down, boom. And then, so that means I'm going to cross out this temporarily, cross out this temporarily. Take that number, flip, and bring it down. Take that number, flip, bring it down. And I'm going to have a CS. And then there's a 1 here. I'll draw that in pencil dashed, and then it's a BR, and then a 1 right here. We do not write 1s, so those 1s are not included. So the formula, the correct formula for cesium bromide is just CSBR, just like it is in the blue without the pencil marks. Okay, fantastic. Let's do the next one. The next one is sodium sulfide. So sodium is the cation and sulfide is the anion. So at least I know in relative areas where to look. So sodium. So I'm going to find sodium on my periodic table. It is right here. There's sodium. That's an Na. You can see that it's in the 1 plus category. So alternatively, you can find it on my ions sheet of paper. And that is sodium, and that is an Na, and that's in the monoatomic cations, 1 plus charge. So I'm going to write Na with a 1 plus, just like that. The next one is an anion, and that is sulfide. That is coming from the sulfur atom. And so where is sulfur on our periodic table? It is right here. Here is sulfur right there. There's an S, and it is in the 2 minus column. It's a non-metal. Alternatively, you can find the sulfide ion right over here in, so it's sulfide. It's in the 2 minus category. It's a capital S and a 2 minus. So I'm going to write that down. That's a capital S and a 2 minus. I'm going to do the same thing. I'm going to take the bull by the horns. I'm going to flip, bring it down. So that is circling this cationic number and the anionic number. Cross that plus out, cross that minus out, flip these numbers and drop them down. And I will get the following formula. I'll be Na, and then I'll write this in another color here so you can clearly see it. That's a 2. And then an S, and then that number that drops down is a 1. We don't write the 1, that's why it's in pencil, and you should be able to erase that, right? So that is, you're going to erase all these pencil marks. They do not belong there. They're wrong if they do, because just assumed. Okay, the next one is calcium chloride. So calcium and chloride. Calcium must be the cation, chloride must be the anion. So I'm going to find calcium on my periodic table. And here it is. There's calcium. That's a capital C, lowercase a. That is in the 2+ category or group 2. Alternatively, we can look at our anions. And it is a monoatomic anion. It is calcium. It's in the 2+ category. It's a Ca with a 2+. All right. So either one of those will work for you. That's a Ca and a 2+, and then chloride. Okay, that was right next to something else that we already did, next to the bromide. So that's from the chlorine atom. That's a Cl. It's in the 1- category. That's a monoatomic anion. Alternatively, you can look at my ions sheet of paper right here. It's in the monoatomic anions category. It's a chloride. It's a 1-. That's a Cl. Capital C, lowercase l, 1-. So I'm going to write that down. Cl 1-. You're going to take the bull by the horns, flip, bring it down. So I'm going to circle these two numbers, get rid of that positive, get rid of that negative. That 1 comes here. We don't write 1s. That 2 comes there. We most certainly write that. So that's going to be a Ca with a 1 in pencil that is actually not there, and a Cl with a subscript 2. There's calcium chloride. Perfect. Just like that. Next one is cadmium phosphide. Cadmium must be the cation. Phosphide must be the anion. So I'm going to find cadmium. That's a periodic trend on my periodic table. There is actually a diagonal pattern there and going down. This is a 1+ for silver, a 2+ for zinc, a 3+ for aluminum, and a 2+ for cadmium. So there it is. That's CD. CD with a 2+, that's perfect there. And then it is phosphide. So phosphide is also a periodic trend, and that's coming from phosphorus. That's a P, and that is in the 3- column right there. So that is a P and a 3-. Alternatively, you can look at my ion sheet, and it is most certainly there as well. And let me show you where that is. Okay. So the first one was cadmium, and that is a monoatomic anion in the 2+ category. It's cadmium right there, Cb2+. And then the second one was phosphide, and that is a monoatomic anion. And that would be a 3-. That's phosphide. That's a P and a 3-. So hopefully that's where you get both of those right there. I'm going to circle this number, the cationic charge, circle the anionic charge, scratch out just temporarily the minus and the plus. I'm going to take the bull by the horn, flip, bring it down, and then I'm going to get the following formula. I'm going to get CD and a 3, and then it is a P and a 2. Should put that in red there for you. So there we go. Perfect. And again, just as a little reminder, and this is something I discussed on a previous video, but I'll write this down here just for you on this one, because it does make sense on this one in particular. The net charge on a compound for an ionic compound is going to be 0. So that's ultimately what we're doing. So CD, that's a 2+, and a P that's a 3-. I need to find a way to add up these two charges such that they equal 0. Right now, if I were to add up those two charges, that equals a -1. If I add another cadmium, so a total of 2 of them, I would have a 4+ charge and a 3- charge. And if I were to add up all these charges right here that are circled, I would have a 1+. That doesn't work for a net charge of 0 either. So then I'm going to have to add another phosphide. So I'm going to add this up. That's a 4 plus, and this is a 6 minus. That will be a 2 minus when I sum these numbers up. So that does not work. So I'm going to have to add another 2 plus charge. Now I have a 6 plus and a 6 minus. That does add up to a net charge of 0. So I'm going to add up these. That equals a net charge of 0. That's ultimately what we're trying to do. You see, it required 3 cadmiums, that's why there are 3 cadmiums, and 2 phosphides, in order to come up with that formula, CD3P2. That's ultimately what we're doing for an ionic bond. We're coming up with a net charge where it equals 0. All right. That is the rule, and that's how it works. I'm showing you a shortcut by taking the bull by the horn, flip, and bringing it down. All right, let's do the next one here, and the next one is tin 2 fluoride. So that Roman numeral tells you actually what the charge is. Since it's the first thing, it's obviously positive, and that is a Roman numeral 2, so that's a 2 plus. And then it's fluoride, that is the anion. So tin is on the periodic table. It is also a periodic trend. So if you are following your periodic trends, there's tin and lead. Both tin and lead both have a 2 plus and a 4 plus. They both have a 2 plus and a 4 plus. Okay. All right. Fantastic. The other name for this would be stannous fluoride. Okay. That would be the common name would be stannous fluoride. But you see that in this column, I have systematic or common name. It's entirely up to you, but it would be stannous fluoride. That would be the common name for this. So if you were to look on my ion sheet, you will find that in the middle of my ion sheet, you have a section called the transition metal cations. These have multiple charges, and we are looking in this category here. We are looking for tin Roman numeral 2. It's SN with a 2 plus, and there's the common name of stannous. So hopefully that will work for you. Then what else did we have on this one? Well, we had a fluoride. So we need to find the fluoride. And the fluoride is a periodic trend as well. And that is right here. That is coming from fluorine. That is a 1 minus charge. Alternatively, you can look at my anion sheet, and it is right here. And that is a monoatomic anion fluoride in the 1 minus category and an F1 minus. So what do we have? We have SN, that's a 2 plus, and an F, that's a 1 minus. Okay, I'm going to circle this cationic charge, the anionic charge, cross out the plus and the minus, take the bull by the horn, flip those numbers, bring it down. I'm going to have SN. I'm going to pencil a 1 that does not belong there. I'm going to have an F and then a 2. So that is tin 2 fluoride or stannous fluoride. Okay, fantastic. Now what we're going to do is we're going to do the next one. That's a tin Roman numeral 4. It must be a cation because it's coming first. That's a Roman numeral 4, so that's a 4 plus charge. And I just let you know that tin does have 2 different charges. That's a 2 and a 4 respectively. Okay. And then it's a fluoride, so we just did that one previously. So that would be an F with a 1 minus. That is a periodic trend, like I discussed before. That is fluorine as an atom, and as an ion, it is fluoride with a 1 minus charge. You can find that fluoride on the ion sheet right there. That's the fluoride. Now we need to find tin Roman numeral 4. So tin Roman numeral 4, because it has a Roman numeral, it is in the middle with the transition metal cations category. That's tin Roman numeral 4. That's SN with the 4 plus, and that's stannic for a common name. So this is actually stannic fluoride. But we're going to do SN4 plus, just like that. I'm going to take the bull by the horns, flip and bring these numbers down. That 4 comes here, that 1 comes here. I'm going to have SN with a 1 that we don't write. I'm going to have an F, and I am going to have a 4, just like that. So that's stannic fluoride or tin 4 fluoride. All right, what we need to do is we need to move this sheet of paper up a little bit so that we can do some more of these problems. I got more to do. So I'm going to move this up here, and there we go. This next one here is iron 2 oxide. So we got the cation of iron 2. It's a 2 plus charge because it has a Roman numeral 2. And then this must be the anion, which is oxide. So I'm going to first find that iron Roman numeral 2 that is in the transition metal cation. And it is iron Roman numeral 2. That's Fe2 plus, and that is ferrous. Okay, so I'm going to write that down. Ferrous. So it's ferrous oxide. And that's an Fe with a 2 plus. Okay, and then it's oxide. Oxide is a monoatomic anion, and that is right here in the 2 minus category. There's oxide, that's an O with a 2 minus. So I'm going to write that. O with a 2 minus. I'm going to circle this number here. That's the cation. Circle the anion. Scratch out the plus, scratch out the minus. I'm going to take that number, bring it down, take that number, bring it down. Now, it will be Fe with a 2, and I'm going to put this in pencil, and then an O with a 2. Now, something about these 2's, and I'm going to circle them. See these 2's? Can they be reduced? Oh, yes, they most certainly can. So if you can, you must reduce. So that is, I'm going to erase those 2 numbers. So now the correct formula for ferrous oxide is FeO. All right. I'm going to do one more thing here, and that is show you that the transition metal cation of iron does have 2 different charges. So there's some periodic trends here, and I'll go over them. This is a 1 plus for this column here, 2 plus for this column, 3 plus for this column, 4 plus for this column, a 5 plus for this column, and look, there's a Roman numeral 5. I have counted 5 elements, 5 columns, if you will. Now I'm going to count 5 more elements, okay? And that is 1, 2, 3, 4, and 5. So these 5 elements have 2 charges, a 2 plus and a 3 plus. So that's a Roman numeral 2, Roman numeral 3. And you should see that iron, Fe, is right here. The lower charge is a 2 plus, the higher charge is a 3 plus. We just did the lower charge of ferrous, and that would be iron Roman numeral 2. There's also a ferric, and that's an iron Roman numeral 3. All right, so hopefully that works for you. Those are periodic trends for you. All right, let's do the next one, and that is iron. It's a Roman numeral 3, so that's a 3, and it's a plus. And then the oxide, we already did that one. That's the anion. So we should be kind of familiar with this one here, and that is ferric, and then oxide. So, and that is an Fe with a 3 plus and an O with a 2 minus. Now, I'm just writing this down here because we've already done some of these and the ferric is really, really close. So let's just verify and validate these. And that is, this is iron Roman numeral 3. That is called ferric. That is an Fe3 plus. So validating that. Then it's the oxide. We've done the oxide already before. And here it is again. There's the oxide, the 2 minus and an O with a 2 minus. Again, we can find both of these on the periodic table. There is the iron, and it is a 3 plus. And here is the oxygen. And there is oxygen. It is a 2 minus, and that is the oxide. All right, perfect. So what I'm going to do is I'm going to come up with the formula. I'm going to circle the cation, circle the anion. I'm going to cross out that positive, and I'm going to cross out that negative. I'm going to take the bull by the horns, flip, bring it down. I will get an Fe2, and then an O, and a 3, just like that. Okay, perfect. The next one is going to be sodium hydroxide. Sodium, we've already done sodium in the second one here, and then hydroxide we haven't done. So sodium is Na with a 1 plus, and just to verify that, That is group 1 sodium, that's 1 plus. It's in the monoatomic cation category, and that is right here. That's an Na 1 plus sodium monoatomic cation. Then we have hydroxide. Hydroxide is the first polyatomic anion that we are dealing with here. So on this lower portion of this ion sheet are the polyatomic anions and one polyatomic cation. The single polyatomic cation is called the ammonium ion. I will circle or highlight that in a different color. That's NH4, that is the ammonium ion. There is only one polyatomic cation, and there it is, ammonium ion. We are looking for hydroxide, and it happens to be in this 1 minus category, and it is hydroxide, and that corresponds to a formula that is an OH with a 1 minus. So I'm going to write that down. So that's going to be an OH with a 1 minus. So I'm going to circle this cationic charge, circle that anionic charge, cross out the plus, cross out the minus. I'm going to take the bull by the horn, flip, bring it down. I'm going to get those right there. And then I will have Na, and then I will have a penciled 1, which we don't write. I'm going to have an OH, and then I'm going to have parentheses around every single polyatomic ion, and then this is a 1. Do I write the 1? No. Consequently, I do not write the parentheses either, and I certainly don't write that one. So there we go. Sodium hydroxide, that's NaOH. Perfect. The next one is going to be lithium nitrate. This is a cation. This is an anion, like on all ionic compounds. I need to find lithium. Lithium is here on my periodic table, and that is lithium. Sorry, not on my periodic table, on my charges and ions and oxidation numbers, and that's Li1 plus. It is also on the periodic table, so let's go back over to that. There is lithium right there, and it is in the 1 plus category. So it's group 1, and that's why it's 1 plus. So I'm going to write that Li, and that's 1 plus. Perfect, just like that. And then it's nitrate. So that happens to be a polyatomic anion. So I'm going to look in the polyatomic anion category. I am going to try to find nitrate. There is nitrate right there, and there we go. And that's NO3 minus 1. Hey, here's a little joke for you. Why do chemists like working at the night? Well, that's because the nitrates are much better than the day rates. Okay, hopefully you got that. So nitrate is NO3 with a minus 1, just like that. I am going to circle this, circle that. That's the cation, scratch out the plus, the anion, scratch out that. Take the bull with the horn, flip, bring it down, and I am going to get the following formula, Li, and I'm going to pencil mark this dashed 1. Then I'm going to write NO3. And then I'm going to put a 1 outside of these dashed parentheses. Do I write 1s? No. Consequently, I don't write the parentheses either. All right, I'm going to scroll this up here a little bit. We got some more problems to do. Okay, and so this next one is going to be barium hydroxide. That's a cation, that's an anion. Barium. Barium is right over here. It's a monoatomic cation, and it is barium, and that is a Ba2 plus. It's in that 2 plus category. Alternatively, you can find barium right over here, and that is, there we go. Barium, it's Ba, and it's a 2 plus category. So Ba and a 2 plus. We've actually already found hydroxide. It's a polyatomic ion. You can find it no other place but right here. That's hydroxide. That's an OH1 minus. So that's OH and a 1 minus. So I'm going to take the cationic charge, circle it, the anionic charge, circle it, cross this out, take the bull by the horn, flip, bring it down, and what I'm going to get, I'm going to get a Ba and a pencil marked 1, which we don't write. I'm going to write an OH, and then the number outside the parentheses this time is a 2. So I'm going to write down the parentheses. They do belong there, and that is a 2, and then that is the correct formula for barium hydroxide. Perfect. All right, the next one is going to be a zinc nitrite. So zinc is also a periodic trend, and it's a monoatomic cation. So it's in the monoatomic cation category, A2 plus. There is zinc, it's Zn2 plus. Okay. Alternatively, you can find it on the periodic table. I already went over this here just briefly, and that is right here. That's zinc, Zn2 plus. So I'm going to write that down. Zn2 plus, and then nitrite. And so that is a polyatomic anion, nitrite. So nitrite is different than nitrate. There's a single letter difference between the spelling of the two, and there's a one number difference between the two. So nitrite is NO2 minus 1. So that is NO2 minus 1. I'm going to take the charge. I'm going to take the charge of the cation, scratch out the plus, scratch out the minus, take the bull by the horn, flip, bring it down, and then I will get Zn with a penciled 1, which we don't write, NO2, and then the number outside that is a 2. So I'm going to require parentheses and that 2. Perfect. You guys are doing a fantastic job. Hold on. We only have, I think, 5 more to do on this half. So let's scroll up here and let's see what we've got. Okay, this next one here is aluminum selenide. I know this is a cation. I know that's an anion. So aluminum is a monoatomic anion. It is a 3 plus. There it is, aluminum, and it's Al3 plus. That's also a periodic trend. I actually slightly went over that, not in detail, but it is right here. There is aluminum right there, and it's Al3 plus. So I'm going to write Al3 plus. Selenide is a monoatomic anion. It's also a periodic trend. So selenide is right there. It's a 2 minus, and it's an Se2 minus. Alternatively, we're going to look at our periodic table. We're going to find it right over here. There's selenium for selenide. That's Se, and that's in that 2 minus column right there with oxygen. So that is an Se and a 2 minus. So I'm going to take this, circle it. I'm going to take this, circle it. I'm going to scratch out the plus, scratch out the minus, take the bull by the horn, flip, bring it down, flip, bring it down. I will get Al and then a 2 and then Se with a 3. Perfect, just like that. The next one is aluminum sulfate. So I know this is a cation. I know that's an anion. We already did aluminum, so that was right before this. So I'm just going to write Al3 plus. And then sulfate is a polyatomic anion, and that is in a new category here. It's a 2 minus for sulfate, and there is sulfate that corresponds to the following formula of SO4 2 minus. You cannot find that on the periodic table because it's a polyatomic ion. So you either have to have my ion sheet or you have to have it memorized, one or the other. I'm going to take the cationic charge, circle it, the anionic charge, circle it, cross out the plus, cross out the minus, take the bull by the horn, flip, bring it down. Got lots of numbers to write here on this one. This is Al and the subscript 2, and then it is SO4 and a parentheses with a subscript 3. Perfect. That's great for aluminum sulfate. All right, scrolling this on up here for a little bit more. We've got 3 more to do. This next one here is zinc sulfite. That's different than sulfate. So we've already done zinc before. Okay, it's a periodic trend, and I'm going to point that out here. There's zinc. It's a 2 plus because it's 1, 2, and 3, and 2 and 2. That's zinc 2 plus. It's also in the 2 plus category of the monoatomic cations, 2 plus, zinc, and Zn2 plus. So that's Zn2 plus. And then I find sulfite. Sulfite is a polyatomic anion, and that is in the 2 minus category, and that's right next to sulfate, and that is Right here, following formula, SO3 2 minus for sulfite. Okay, so that's SO3 2 minus for sulfite. I'm going to take the bull by the horns. I'm going to circle these two numbers. I'm going to scratch them out, flip, and bring them down. Oh, wait. Check this out. ZN, and then I'm going to write this in pencil here. 2. SO3, parentheses, and a 2. Can you reduce that 2 and that 2? The answer is yes. These will be reduced to ones. Consequently, I don't write the parentheses and I don't write the 2's, and most certainly we don't write the 1's. If you write the parentheses, that's correct. It is wrong, so don't have the parentheses. Okay, zinc sulfite. There it is. All right, the next one is going to be zinc phosphate. So zinc and phosphate. So we've already done zinc. We just did it right before this. I'll take the liberty of writing that down. And now we need to find phosphate. So phosphate is a polyatomic anion, and it is in the -3 category, and that's PO4 3 minus for phosphate. So that's PO4 and a 3 minus for phosphate. I'm going to take the cationic charge, the anionic charge, circle them both. I'm going to scratch out the plus, scratch out the minus, and then take the bull with the horn, flip, bring it down. These numbers will not be reduced, so I will have to write them down. So that is ZN, and then a 3, and then it is PO4, parentheses, and a 2. So there is zinc phosphate. Perfect. Scrolling this on up here. Notice that I have a bunch of blank space here, and that's just for you to, write some notes if you need it. All right, the next one is zinc and phosphite. So again, cations come first, anions come second. We have already done zinc, so we've done it before. We need to find a phosphite. And phosphite is right over here. It's right under phosphate. It's in the 3 minus category, and it is PO3 3 minus. So PO3 3 minus. Perfect. I'm going to take the cationic charge, circle it, the anionic charge, circle it, and cross out the plus, cross out the minus. Take the bull by the horn, flip, bring it down. And what will be the formula I will get? I will get Zn, a subscript 3, phosphite, that's PO3, and then a parentheses and a 2. Perfect. All right, folks, that is it. You've been watching The Crazy Hat Chemist. And oh, by the way, this is only part 1 of this video series here of ionic bonds Roman numeral 5, because what do we have on the back side of this? On the back side, this is what we have on the back side. On the back side, we have formulas. And what do we need to do? We need to figure out what their names are for these formulas. So that is going to be the second part of this video series, is we need to find out from these formulas, what are the corresponding names. We're going to do that the next video. So find that out on the next video. Like and subscribe. Give me a thumbs up. Appreciate it. You are watching The Crazy Hat Chemist. So have a fantastic day. Good night. So long. Farewell. Auf Wiedersehen, as they say. Arrivederci.